Hello, in this video we'll try to look at the concept of rationalizing denominator. There was one more video on the same channel, so if you want to watch it, go back and watch that one. In that question, actually in the denominator we had only two terms, so I was able to rationalize it very easily. Let's look at that. So that root 3 minus root 2, then when I wanted to rationalize that, I was able to multiply and divide with a different sign, root 3 plus root 2. Same thing with a different sign. The reason for that is you are rationalizing the denominator, in the sense there are no irrational numbers in the denominator. How would we do that? If I take this, it looks like a plus b into a minus b, which is a square minus b square. And if I do the same thing, root 3 square minus root 2 square is actually going to give me 3 minus 1, which is equals to 2 minus 2, sorry, that will be 1. There were two terms. So in this question we have three terms here. You have two options. So what you can do is, either I can go with root 5 minus root 2 minus root 7, put bracket somewhere, so that way actually you can assume this as 1 and that is 1, or you can also go with root 5 minus root 2 minus root 7, that is 7. I can put somewhere here as well. See here what happens, you just put the brackets, but this, if I open the bracket, this is actually going to be wrong. So usually 5 minus is out, so minus, keep it as is, no problem. This will be root 2, that will be plus root 7. So it's not just about putting brackets, but make sure where you put brackets and verify that. Are you going to get that step back again? If you don't verify, you continue with this, this is actually going to be wrong. How is this? The root 5, nothing is there, plus into minus, minus root 2, minus into minus, plus root 7. According to that, that is not the one what we are looking for. So it's not just about putting brackets, where you put brackets. So let's keep this aside and I'll go with this one. So what we'll do is 1 divided by root 5 minus root 2 minus root 7. Keep brackets here. Even if I verify, bracket opens and then I still have the same value. Let's rationalize the denominator exactly like what we did for two terms. I'll consider root 5 minus root 2 as whole one term, and I'll keep the rest as the second term, that is whole one term. Change the sign, root 7 divided by, I'll do the same thing for root 5 minus root 2 plus root 7. So as I mentioned, this is a minus b, a plus b, a square minus b square. So here if you look at that a square, root 5 minus root 2, that becomes my a square, minus b square is root 7 square. This will be a minus b whole square, remember that, a minus b whole square. So a square, root 5 square is 5, plus b square, root 2 square is 2, minus 2ab, 2ab, sorry, 2ab, minus, then this root 7 whole square is 7. So what is going to happen? 5 plus 2 is 7, minus 2, 5 into 2 is 10, with the same power here, index, minus 7. 7 plus 7 minus 7 gets cancelled. I'll be left with minus 2 root 10. So that's what I'm going to actually use it straight here. The top one stays as is, root 5 minus root 2. If I take out bracket, nothing is going to change, plus root 7. I'll just open the bracket. It's not going to matter much. A square minus b square. This a square is actually going to give me minus 2 root 10 and b square. Yeah, we have done the whole thing. A square minus b square minus 2 root 10. So now, did I actually rationalize the denominator? No, I'm still left with root 10. So you have an option. So rationalize the denominator again. Root 5 minus root 2 plus root 7 divided by, so what are going to, minus 2, minus I'll keep it as is, minus keep it as is, 2 I will not touch, root 10 is the one I'm worried about, so what I'll do is I'll multiply it by root 10 and divide by root 10. Remember, if there is only one irrational number, so you just multiply. There is no a plus b or a minus b identity you have to use, because you want to get rid of this so that in the denominator you get a rational number. So I'm trying to get rid of that by this. So if I actually cancel this, I'll still have the same thing, so nothing changes with that. So now what happens? Root 5 into 10 is root 50, root 2 into 10 minus root 20 plus root 7 into 10, which is 70, divided by, I still have minus, I'll keep it as is, we'll come back to that minus later. Root 10 into root 10 is 10, and into 2, this is 2, root 10 into root 10, root 10 is 10, and I still have that 2, it will be 20, right? You have 20 there. So what can I do? If I can take anything common here from inside the root, then cancel. Yeah, if not, no. Let's see. Root 50 can be written as root 25 into 2. Root 25 is 5, so if it comes out, it will be 5 root 2. So that is 5 root 2. I'm just trying to find the numbers for which I can find the square root and bring it outside. That's the important thing. 20 can be written as 4 into 5. 4 is 2 square, so it comes out, it will be 2 root 5. That will be minus 2 root 5 plus 70. I can't find anything. 35 multiplied by 2. So the way you can actually check that is, if I prime factorize this, 35, 7 5s are 5 1s are. So as I can see, I will not get any two numbers where I can actually take squares of those, so I'll just keep that as is, can't do anything, divided by minus 20. So that means in these three terms I cannot take anything common which can actually either divide or simplify this. I'll keep that as is. So that should be my answer. But in the denominator we cannot leave negative, so if I'm actually going to take it up, that will be somewhere in the bracket like that. So just to write this in proper form, I'll multiply minus with all of them. So if I multiply this, this is going to be negative, that's going to be negative, that's going to be positive. So for that reason, 2 root 5, I'll write it first because it's going to be positive. Rest of them 5 root 2 and then root 70 divided by 20. So that's actually my final answer. I simplified as much as I can, and I also rationalized denominator. That's all about it.